Hey there! Have you ever just stopped and wondered how all the, well, stuff around us is actually put together? It turns out everything, from the air we're breathing right now to the water in our glass, is either a compound or a mixture. But what does that even mean? What's the real difference? Well, that's exactly what we're going to figure out.
To kick things off, let's start with a little riddle. The salt you sprinkle on your food, is it the exact same thing as the salt in the ocean? I mean, they're both salty, right? But are they chemically the same thing? It seems like a simple question, but it gets right to the heart of what we're talking about today. And trust me, by the time we're done here, you'll know the answer for sure. So, when it comes right down to it, there are basically two main ways that substances can combine. Think of it like this. They can either go through this dramatic, total chemical makeover and become something brand new, or they can just kind of mingle, just hang out in the same space. Let's tackle that dramatic makeover first.
Right, so this first way is all about that transformation. It's where these basic ingredients, what we call elements, get together and combine in such an intense way that they're basically reborn as something totally different. And that, my friends, is the world of compounds.
So here's the official definition. A compound is a substance made of two or more elements that are joined together by a chemical change. And those are the magic words right there. A chemical change means it creates a completely new substance. The original stuff, it's gone. Poof, replaced by something totally new.
And you're literally surrounded by these things all the time. I mean, the water you drink, that's a compound, H2O, right? It's made of hydrogen and oxygen. That table salt we were just talking about? Yep, that's a compound of sodium and chlorine. Even the carbon dioxide you're exhaling right now is a compound of carbon and oxygen. They're everywhere.
So this is the big idea, the one thing you really got to remember about compounds. A brand new substance is formed. It's not just a remix of the old parts. No, it's a complete and total chemical transformation.
Chemists have this really neat step-by-step way of showing how this happens. Let's take water. They start with a simple word equation. Hydrogen plus oxygen gives you water. Then they translate that into the chemical symbols we all know. After that, they have to balance it, kind of like making sure a recipe has the right amounts. And finally, they add these little symbols to show what state everything's in, which is how we see, right there on paper, how two gases react to form a liquid. Pretty cool, huh?
And this right here, this is why that new substance idea is so mind-blowing. Just think about it for a second. Hydrogen, it's a super flammable gas. And oxygen, that's the gas that fuels a fire. So you've got two gases that are all about fire, but when you combine them chemically, what do you get? Water. A liquid that puts fires out. How crazy is that? The properties of the new compound are completely, totally different from the parts that made it.
Okay, so that was the drama of the chemical makeover. Now let's switch gears and look at the other side of the coin, mixtures. And this whole process is way, way less dramatic. You can think of it as substances just hanging out together.
And the definition here is pretty much the exact opposite of a compound. In a mixture, you've got two or more substances mixed together, but, and this is the absolute key, no new substance is formed. There's no chemical reaction, no big transformation, nothing.
This is what we call a physical change, not a chemical one. A great way to think about it is mixing sand and pebbles. Sure, you've jumbled them all up, but have you created some new material called sand pebble? No, of course not. The sand is still sand, and the pebbles are still pebbles. You could even sit there and pick them apart again if you wanted to.
The air we're all breathing right this second is the perfect example of a mixture. It's just a big collection of different gases. You've got elements like nitrogen and oxygen, and even some compounds like carbon dioxide and water vapor, all just swirling around, mingling in the same space, but not chemically reacting with each other at all. And because there's no chemical change, everything in that mixture keeps its own original identity. It keeps its own properties. So, the oxygen in the air, it's still just oxygen, doing its thing, letting us breathe. The nitrogen is still just nitrogen. Nothing's changed about them.
All right, you ready for the main event? We've talked about compounds, we've talked about mixtures. Now, let's put them side by side, a real head-to-head comparison, so we can lock in these differences once and for all.
Okay, this chart really breaks it all down for us. Let's walk through it. First up, composition. In compounds, elements are chemically bonded together. They're locked in tight. But in mixtures, they're just mixed, no bonds. So that leads to formation, right? Compounds are made by a chemical change that creates something brand new. Mixtures? Nope, no chemical change, no new substance. And that changes their properties. Compounds get totally new properties. Remember the water and fire thing.
But in a mixture, everything keeps its own original properties. And finally, and this is a big one, separation. To break apart a compound, you need a whole other chemical reaction. It's tough. But a mixture, you can usually separate it with simple physical methods, like using a filter or just letting something evaporate.
So you might be thinking, okay, I get it, but why does any of this actually matter? Well, it's a great question. And the answer is that this isn't just some boring chemistry rule. Understanding this difference is fundamental to understanding how our entire world is built.
When you boil it all down, compounds are the building blocks for brand new materials. Mixtures are just collections of things that already exist. It's that simple. From the steel in a skyscraper to the salad dressing on your lunch, it's all one or the other. And hey, what about that question we started with? Well, now you know. The table salt in your shaker is a pure compound, NaCl. But ocean water? That's a mixture. It has that same salt in it, but it's all mixed up with water and a whole bunch of other minerals and substances.
So I'm going to leave you with a little challenge. Just look around you right now, wherever you are. Look at the plastic of your phone, the wood of the table, maybe the coffee in your mug. Can you start to see the world a little differently now? Can you spot the hidden compounds and the simple mixtures that make up, well, everything?